Yo kids, this is the walkthrough of your mymaths this week. Just shut the door. And of course in the lesson we were looking at volume and surface area of trickier shapes like cones and spheres and cylinders. And on your mymaths homework as well, they even include pyramids, which we didn't talk about yesterday. That's not a problem. And I'm actually going to go through it under the visualizer this week because I got a new bit of kit and I want to try it out, which is awesome. So your feedback will be welcome on that. There we go, let's make it as big as possible. Right, so obviously we're going to start with this one. That's a cone, and for all of these shapes here, we have to find the volume, right? I haven't given you any surface area questions this week. It's just all about volume. So the volume of a cone is 1/3 pi r squared h. Right, so we know that now from yesterday's live lesson. So if we look at this, they don't give us the radius, they give us the diameter. So there's your opportunity to make a mistake there. So it's 1/3 times pi times, now the radius will be half of that, so that's 6.5 squared times the height, which is 10. And then you chuck all that in the calculator. Right, now I will actually chuck it in the calculator for this one. So I've got 1/3 times pi times 6.5 squared times 10. And your calculator will say that, right? And if you look at the top of the screen, it says it wants it to 1 decimal place. So make sure you round it correctly. So in this case, that's 442.4. It does the units for us, centimeters cubed. Right, so nice easy one to start. Question 2 is another cone. So I'll use the same formula. This time they do give us the radius. So I'll just type in 1/3 times pi times 4 squared times 13. And then round that to 1 decimal place. I'm not going to do that one for you. All right, this one here, that's a pyramid. And believe it or not, a pyramid has the volume of 1/3 of the box that would surround it. Right, very similar to that of a cone. That has the volume of 1/3 of the cylinder that would surround it. A pyramid, the volume of a pyramid is 1/3 of the cuboid that would surround it, right? So the volume of a pyramid is 1/3 times the length times the base times the height. That's all you've got to do. So here the length is 11, the width is 6, the height is 12. I should have called that width really, shouldn't I? Okay, so it's length times width times height. Type that in the calculator. Actually, we can do this in our head, right? 1/3 of 6 is 2. 2 times 12 is 24, and then 24 times 11 is 264, right? So that's 264 centimeters cubed. Didn't come out as a decimal, so you don't need to round it to a decimal place. Similar for this one then, that'll be easy. We'll do 1/3 times the length, 7, the width, 8, times the height, 5, and get the answer. Okay, no problem there. Right, these last two are about spheres. So the volume of a sphere is 4/3 pi r cubed. So this one's quite easy. So you're just going to type in your calculator 4/3. You're going to times it by pi. The radius is 1.5, and that needs to be cubed. All right, so I'm going to use my lights on that. I'm going to use my fraction button, my ABC button, to get 4/3. I'm going to times it by pi, and I'm going to times it by 1.5 cubed, and my calculator says that, and I need to round it to 1 decimal place, so that's 14.1 centimeters cubed. The last one has got an extra bit to it. First of all, it's a hemisphere, not a whole sphere. So when I do get the volume of the whole sphere, I'll need to divide that by 2. And of course, they give us the diameter, not the radius. So be careful there, right? So the last one, I'm going to do 4/3 times pi times. Now, if the diameter is 3, the radius is 1.5. 1.5 cubed, and when I get all of that answer, I'll then divide it by 2 because it's a hemisphere. Round it to 1 decimal place, job done, right? So I'm not going to do that one, you can do that one. Nice and easy. On to the harder questions on question 2. Well, they're not really that much harder. Let's tackle this one first. So here I have 2 cones back to back, effectively, right? So to get the volume of that whole shape there, I need to find the volume of one of the cones and then double it, right? So the volume of a cone is 1/3 pi r squared h. Let's see what information they give us. Right, they've given us this distance here is 7.4. And of course, half of that distance from there to there will be the height of one of the cones. Half of 7.4 is 3.7. Right, so I'm going to do 3.7 in there. This distance here is the diameter of the base, and of course we need the radius, so we need to half that. Half of 5.4 is 2.7, and that will be squared. That will give me the volume of one of the cones. There's 2 there, so once I do all that, I'm going to have to multiply it all by 2. Right? So I'll just do it on the calculator. What we got? 1/3 times pi times by 2.7 squared times by 3.7, and then times it by 2 because there's 2 of them, and that's what it says. And they want it again to 1 decimal place, so for me that's 56.5 centimeters cubed, no problem. The second one, the red one, that's a composite shape of a cone and a hemisphere. So let's do the cone first. The cone, 1/3 pi r squared h. So 1/3 times pi. Right, what's the radius of this? Now, they haven't directly given that information there, but they have told us it in another direction here. Right? Of course, on a sphere, any distance from the center to the edge is the same. So the radius of that base of the cone is 3.6, and that will be squared, and the height of the cone is 4.8. So I'll type all of that in and get an answer. Not going to do it. To get the hemisphere then, the hemisphere is 4/3 pi r cubed, which is obviously 1 whole sphere, and then I will divide that by 2. So that will be 4/3 times pi times, now the radius of the sphere is 3.6, so 3.6 cubed, type that in, divide it all by 2, and I'll get an answer there. And then of course to get the total volume of the solid, I will get this answer and add them up. Okay? Now I wonder, maybe you shouldn't round it too soon. Maybe you should write out the full answer for the cone, the full answer for the hemisphere, then add them up, and then round it to 1 decimal place, or you might lose a rounding mark somewhere. Okay? Right, and the last one is usually the trickiest, and I got a feeling it is. Let me just scroll it up a little. It says the Great Pyramid of Cheops is a square-based pyramid, and the base has sides 230 meters, and the height is 147, right? So in my best artistry, no laughing here. So that's 230, that's 230, there's the top of the pyramid, and the height of it is 147. All right, so what's the volume of that pyramid? So the volume is 1/3 times the length times the base times the height. So I'll do this one. So that's 1/3 times 230 times 230 times 147, which comes out as that 2,592,100 cubic meters. Right? So that's the volume. Now, it then says, using the same materials, so we've got the same bricks, what would the height be if the base changed? So what would the height of the pyramid be if the base sides are no longer? So obviously the height is going to be shorter. So let's draw another very crude diagram here. So if I had 280 there and 280 there, but I use the same number of bricks, which means I effectively have the same volume there, what would the height be? So I know my answer to the volume is 2592 100, and I know that's 1/3 times by 280 times by 280 times by the height. So what I'm going to do, I'm going to work that out, and then bring that worked out all over here as a divide, and that will give me the height. Or I could do it in one step using brackets. Check this out. So there's my answer to the volume. I'm now going to divide it by 1/3, or there's my phone, 1/3 times 280 times 280, and it comes out as 99 3/16. So you need to press your SD button on that to work out what it is as a decimal. So it'll be 99.2 meters. That's what the height would be. So if I changed the base length to 280 each, but I had the same amount of bricks, i.e. the same volume, then the height of that pyramid would be 99.2 meters. And that's how you tackle this week's My Maths. No excuses for not getting a green. Make sure you write down all the formulas and round it correctly. All right, and that's it. Nice one. See you next time.